Hey y'all. Today we're going to go over scatter plots. And so you have a packet of notes, and I'm going to go through those so I know I'm upside down. So make sure you have your scatter plot notes, and we're going to get started. Okay, so I know this says notes 4, 5, 7. So scratch through 5, 7, please. And we are going to talk about scatter plots and trend lines. First, we're going to talk about scatter plots. And some vocabulary words. A scatter plot is a graph that compares two different sets of data. And it's down here. If you like to highlight, then you can highlight, but here's the definition of scatter plot. You are going to plot points as ordered pairs, and you're going to see a bunch of dots on the graph. Most scatter plots are in the first quadrant because most of them deal with positive numbers if they are real-world application problems. But not always, but most of the time. Now, a scatter plot is going to have a correlation. So you should see these three graphs. These are examples of different correlations. In this first one, if you notice, all the dots are kind of going in an up direction from left to right. This is called a positive correlation because as x increases, so does y. And it says it right here, when y tends to increase as x increases. Both values need to be increasing. If both values are increasing, then it's going to be a positive correlation. And the same is true if both values are decreasing, then it would still be a positive correlation because they're both moving in the same direction. Now in the middle here, if you notice, the scatter plot is graphed, and a scatter means like all the values are scattered. This is moving in a downward direction from left to right with a negative slope, and so this would be a negative correlation because y decreases as x increases, or it could be vice versa. One has to decrease and one has to increase. So these are kind of opposites when it comes to their data values, and that's going to make a negative correlation. Now this last one over here has no correlation because the dots, if you can see them, I know they might be light, they're just kind of everywhere. They're not really in kind of a negative or a positive direction. And so if they don't relate to each other at all, then it would be no correlation. So I'm just going to give you a few examples of all of these. So you're just going to write these down right here. For a positive correlation would be something like the hours you work and the amount of money you make. The hours you work and the amount of money you make. This would be a positive because as the hours you work increase, the money you make increases. So this is an example of a positive correlation. A negative correlation means one has to increase and one has to decrease. So for this example, you could say the amount of time exercising and someone's weight. In theory, now again, this is theoretical, but in theory, if you increase your exercise, as this increases, your weight would decrease as a whole. If someone exercised more and ate the same, then their weight would decrease. This would be a negative correlation. No correlation would be something like the number of letters in your name and your math grade. The number of letters in your name and your math grade. As the number of letters in your name increase has no bearing on what your math grade is. You could have a 3-letter name like Wes, and you could make a good grade or a bad grade, or you could have a really long name like Sebastian, and you could also make good or bad grades. So this would be no correlation. That's just a real-world example of all three. All right, so let me go back to the vocabulary. Scatter plot, positive, negative, no correlation. Trend line. Here, we are going to talk about trend line, and that's going to be in our next video all about trend lines and lines of best fit. So today we're just really focusing on what a scatter plot is and how to make it. So at the very bottom, problem number 1, the table shows the altitude of an airplane and the temperature outside the plane. So you have your data, the altitude and the temperature. This would be your domain, this would be your ranges, your x and y's, except they're using m and temperature. And I don't know why this copied weird, but we need to make a scatter plot, so you're going to be flipping back and forth, but go to the top of the next page, and we're going to make a scatter plot with this data. When you make a scatter plot, you need to make sure your axes are both labeled. So notice my altitude, so label your axes. So you want to label your axes, you're going to plot your points. And in this one, it's already been done for you. Notice it's going up by thousands, 500, 1,000, 1,500, 2,000. You don't always have to go up by 1, 2, 3, 4. Over here, they're going up by tens, 10, 20, 30, 40, 50, 60. Altitude and temperature. And then you do need a title. And so the title of this is going to be temperatures outside the plane. Temperatures outside the plane. So we're going to label our axes, plot our points, and that's when you're going to have to kind of go back and forth and look at your chart that you have. The first one, the altitude at 0 is 59 degrees, so right before 60. And I am looking, I have another copy. I'm looking at my chart, so you're going back and forth. 559. 1,000 is 61. 1,500 is 55. So that's 50, so it's going to be more in the middle. 2,000 is 41. 2,500 is 29.8, so that's almost 30. 3,000 feet is 29.9. 3,500 is 18 degrees. 4,000 is 26 degrees. And 5,000 is 0.6 degrees. So that's like 0 point. So way down here. Oh, I skipped one. Sorry. 4,500 is 12 degrees. I was about to say, that's a big jump. So we have made a scatter plot. We have scattered our ordered pairs, and they're not going to be a straight line, but this is a scatter plot. What type of relationship does the scatter plot show? And as you see, as our altitude increases, overall our temperatures are decreasing. So this shows a negative correlation. This is showing a negative correlation because as altitude increases, our temperature decreases. And you can see that our scatter plot, our dots, are going into a negative slope direction. Your turn number 1. Make a scatter plot of the data in the table below. What type of relationship does the scatter plot show? So again, we are having gasoline purchases. Dollars spent, gasoline, gallons bought. Dollars spent is our X, so it's on the X-axis. Gasoline bought is our Y variable. And we just need to plot these numbers. So you go ahead and start plotting them. I just need to check the time. I can't tell if it says 6 or 8. All right, $10 is 2.5. $11 is 2.8. $9 is 2.3. $10 is 2.6. 13 is 3.3. $5 is 1.3. $8 is 2.2. And $4 is 1.1. So these are counting by twos. And over here, the scale here is 0.5. 0.5, 1.5. So that's something you have to be careful about. These axes are labeled. Dollars spent is our X, gallons bought are our Y. And we need to label this gasoline purchases. And I just took the title from right here, gasoline purchases. And the question is, what type of relationship does the scatter plot show? And we can see our dots have lined up to make a nice positive correlation, because as our dollars spent increases, notice these are getting bigger, 4, 6, 8, 10, 12. As our dollars increase, as our dollars spent increases, our gallons bought also increases. So to be a positive correlation, you have to have both values increasing. Okay, let's flip it over. Your turn again at the top. Consider the population of a city and the number of letters in the name of the city. Would you expect a positive, negative, or no correlation between the two sets of data? So the population of a city and the number of letters of a city. Now, maybe it's already coming to your mind, you're like, oh, I know this, but what are some of the most populated cities that you can think of in the United States? So if you come to mind, I mean, Houston is definitely one. New York, Los Angeles. What are some other? Maybe you're thinking of Chicago, or even Miami, Orlando. There's lots of really very popular cities in America. So we could count up all of those letters. Now, if the population increases, does that mean that the city is going to have more letters in it? And hopefully you're like, well, no, it doesn't matter how many letters the city has in it. It has nothing to do with the population. And so this would be an example of no correlation, because the population of a city is not related to the number of letters. Make sure you're getting all this down in the name. The letters have nothing to do with the population. The only thing that has to do with the population is how many people move there, which has nothing to do with the city name. So that would be an example of no correlation. So we have made two scatter plots in our notes, and we've had an example of, is this a positive, negative, or no correlation? Now next time, we're going to start here for trend line. So whenever you have your trend line video, I'm going to pick up here and then explain what trend line is and the rest of this vocabulary. All right, see you in class.